Good morning. Happy Wednesday. Today, I was thinking of continuing with Nature of Code and doing a sort of something similar to what we did last time with velocity and acceleration, but moving up towards, like, accelerating towards something. So in this case, it's going to be accelerating towards the mouse, which is 1.10. See if I can find it. Not that one. This one. So this is the example that has this ball is always trying to move towards the mouse, and I mean it always looks pretty interesting. It's almost like we can. It's almost like we could then simulate gravity and like spatial bodies, like planets moving around a black hole or a star or some other sort of like gravity anomaly. Um, that's kind of like what I'm hoping to be able to do today. I think the interesting thing that we're going to need to be able to do is figure out the direction. So that's going to be a vector subtraction here, or a point subtraction, I guess, in our place. And I'm also going to need to get normalization, because I need to be able to like make it down to like a number that's between 0 and 1, and then I can scale it up by however fast the I want it to go, the speed. So we may have to implement those functions. I haven't looked to see if the NAlgebra library has what we want out of there. What I do have here is pretty much nothing, so we're going to start again from blank. I am thinking about, and this is from a comment last time. Ooh, and I should add this in. I am thinking about adding in a, let's see, you get closed in, a, what is it called in code? I want a snippet. I want a snippet. So how do I create that? Not insert snippet, configure user snippets. This will be for Rust. Place your snippets for Rust here. Each snippet is defined as a snippet name and it has a prefix. So, okay. This kind of looks like JSON. Skarsh, good morning. Yes, it is nice to be doing Rust again. It's a super fun language. I feel it helps me in my day job, and also I just enjoy it. Let's see. Okay, so I guess I'll call this like a GGEZ, like main. Oh, that's okay. So this is the name. So GGEZ main function, or like the main file, and then the prefix is going to be the word that I type and then hit tab. So prefix. I think like I can just do G main. We'll see if I can memorize that. I don't know. I usually don't do terribly well with like shortened words like this. What's that? Oh, I forgot the name for them. All right, so then we have body. Oh, so this is what it's going to be, one per each line. Oh, so that's interesting. So for example, it would be console log there. Let's go take a look at my gist here, because I had created this as the main RS. So I don't necessarily want to use Perlin noise because we don't need that every single time. But we do need this. So use GGEZ, context builder event. I don't necessarily want to edit that. Okay, so I do like $1, $2 for what where my key, like where my mouse, like where whatever my focus goes. And then description log output to. Okay, so then we'll have the description afterwards. So I guess it'll just be one line per time. I guess also if I want a blank line, I just have to have a blank line like that. Can I do? I wonder if I can do what is it, the backticks, and then I don't have to do this per line. That would be interesting. So I would imagine if I do this backtick. Oh right, so it can't handle that because it's JSON. It needs to have double quotes. Backticks don't work. So we'll do that. Oh, and so then this will be interesting. Because Rust is really the difference between double quote and single quote is actually quite big. I'm gonna need to escape these. Okay, so we have context builder new game name. So I'm gonna put this as $1. That should be fine. I have this dot build. What are you upset about? Control characters must be escaped. Is that because I put tabs? Oh, it is, isn't it? You're not tabs then? No, you're not. Okay. Let me try that. Just nothing at all. Okay. Escape that. Escape you. Okay, so we're gonna create a new variable, put all that stuff in it. I guess I could try the last few of these all at once. So you get double quoted and a comma. That is fine. Same thing for you. You get escaped. And a comma. You get escaped. And a comma. And I think that's it. I think that's the Oh, there's this last one right here that I forgot. All right. So theoretically, I should be able to use gmain, and then we have a description. So our description would be the GGEZ. What is this rust.json file? Hey Danny, welcome to the stream. I am trying to create a snippet for GGEZ, like the main file, so I can just type gmain and then all of this will pop out. But apparently it's JSON. And the other thing is they name the language that I'm going to be programming in, or that I want it available in, as the prefix for the .json. Yeah, so for VS Code. So that'll be better than going into someplace else or having to retype it every time. And hopefully this $1 will actually go in there so I can easily reset that. So we're gonna say GGEZ main.rs file for I guess like I don't really need much for that. Stacking, good morning. Back in your day, you made code snippets in Bash, and we liked it. Yes. I also remember that there were code snippet programs that people would pay for and have on their computers. And that is just a crazy idea now, because then they'd just be stuck on your computer and that was it. I know, pay for? Crazy talk. Okay, so will this work? Can I just do gmain? Hey, look at that. So gmain, hit return. Here. Ooh. Okay. I need to clearly gmain up here. This is a problem. These are not tabbed the way I want them to be. So let's fix that. So function main, this is all at the basic. This needs to be tabbed, so I think I could just go like that. So tab in once. This will be on its own line again. This will be on its own line, but this needs to be tabbed. Tab. Oh, all of these need to be tabbed. So this is tabbed twice. Okay, let's try that. Yeah, this looks a lot better. Now, oh, okay, so we have this is our the name of our game state. We might want to update that. New line. So match event.run. So reference mutable context, reference to mutable event loop, view game. Like put this on a new line down here. Oh, just like match one down. I could see that. So, oh yeah, we did want something like that. So if I save you, gmain, all right. So this looks a little bit nicer. We also have this game we need to pull in. So that, okay, so we need to figure out this. Now in the previous one, what did we do for that? We just didn't even save that at all. It's just like, where did it come from? I don't know. What is that? It's let me create the lib. .rs and play around with that. So if I have pub struct game and I don't have anything else with it right now, I have to use and then the name of this entire app star. Oh, right, it wasn't that. Doesn't the snippet want to use $2 for indentation instead of /t? Why use many words when few do the trick? Or just why use few words when many words do the trick? I don't know. I guess like because this is all in one repo, I wanted it to be like readable from like what this is at the basis, but that could just I could see other arguments for it. Also, you're upset because you're not installed. I think that's what the problem is. Because I would need to cargo run to like get that in there. $2. I don't think that $2 will do tabs. I think $2 actually brings the focus of the cursor. Oh, wait. Possible variables are $1 and $2 for tab stops. Oh, right. Okay, so tab stops are different. So like I think what they're looking for is you like press tab and it moves to that next thing you want to write in. So it's not actually an indentation. It's that weird tab stop thing when you have a snippet in VS Code. I also am like always forgetting. Did we use? I now need to like go look at the last one because I forgot from Monday. Let's see the out of here. Go into the. Oh. Exercise. That's what it is. Oh yeah, so we did use this. So it was exactly that. So that's how we did it. Skarsh, good morning. What are we trying to make? Well, we're going to be making a what is it? A sphere or ball that is constantly accelerating towards the mouse. And then the cat vibe.rs, that is, oh, we'll just use, oh, right, mod. We have to use mod ball, and then we can use that. Okay, got it. But until then, what I'm setting up is this snippet that I can use. That is why I'm using GGEZ, yes, for the graphical part. Indeed. It's a fun game engine. So you're just upset right now. Okay, well, and input, yes, absolutely. Context builder, so you're all upset, I think because I haven't compiled it and run like that. But let's put this in here. So we have use GGEZ. We're also gonna have this use, and then it's gonna be dollar. So this will be $1 star. That will be the name of the. This will be the name of the full app, I guess. So in here, this will be $2. And I think I think that is everything we need for this file. So let's try it fully. So if I come in to Kaggle Tamil, I save that, delete everything, gmain, so use, hit that, hit tab, come down here, and we'll just say accelerate towards mouse. Why did that reset? I don't remember hitting that. Yes, that is what the $2 is for. Can you have any logic and code snippets to grab the project name? Probably not. I don't think you can because it's just a JSON file. It's not going to execute this code, as far as I can tell. All right, so I'm going to save this. Let's go over to the library and get this set up now. So this is what we want the end result to be like. So we need to use GGEZ, context game result graphics, the event handler. We also know we need to use the points. VS should have logic, but I guess they have no way to grab it. That would make it more full-fledged. I mean, does Sea Lion have in their snippets the ability to like actually have logic in their snippets? Well, okay, that's true, Danny. We could create an extension, and instead of a snippet, it's just an extension that acts like a snippet. That could be interesting. Okay, so this is, we create the game struct, we have new. It's just basically very basic stuff at this point. So let's, first of all, I want to make sure that this works. Hey, look, all these errors went away. I think the other thing was RLS took a while for it to like search through everything. Also, ooh, I forgot a semicolon there. That's important. Let's fix that. Semicolon. And now this is going to go down here. So GGEZ lib. Okay, so we'll have our prefix. This will be glib. We'll have our body, which will be an array. Now that's interesting. It didn't automatically do an array, so I maybe I could get away with not an array, but all right, so we're gonna take you, copy you, paste you in here, and we'll fix you. First of all, does anybody know what the command is to get individual commands? Like, it's not Command Shift L. No. Yeah, I don't know what the command is to get new lines for each one, but I can do this just. Uh-oh. And not you, not you. Okay. Okay, I think think that's everything. So I would do quote, home, quote, and comma. All right, so now we clean it up. All right, so use GGEZ, context, game, result, graphics. You know what else I can do to remind myself of how the entire library system works? We could have a mod $1 here. And that will be to remind us like, hey, we need to mod this. And then down below here, I'll do another new line. We could have a use $1. So this will update both of them at the same time. Probably something like that. What's the, oh, how did I, okay, that's interesting. You need to be closed. This somehow got into 2 lines. Use GG events, okay. Let's move you up to be up here. Yeah, my formatting got really weird. Okay, so mod $1, use GG, context, game result, graphics. Event handler. It's fine for that. Okay, use $1 and then everything inside of that. New line, and then here we begin our public struct name or game. I don't think we need semicolons after that. New line, then we implement. So we implement our game. There are comments in the JSON file, so it's probably using JSON superset language. Yeah, that's probably true. Or it's like converting this to a real JSON later. Okay, so we implement game. We're going to want to tab this in, public function new. We take in underscore context game. So then this is going to be twice tabbed in. And then single tab. And then not tabbed at all. New line. So implement event handler for games. That's fine as it is. This will need to be tabbed in. This will need to be double tabbed. And single tabbed. Single tabbed. All of these seem to be pretty simple so far, so I don't need to do anything more than just double tabbing it. I don't think I need to do the keyboard, like grab the cursor parts. Graphics present, this is double tab. This is single tab. And this is nothing. All right, let's try it. Let's see if it works. So this is glib. So here with mod, so I would potentially put in our ball. So we want to use everything inside of there. We got some double colon problem. Oh yeah, I see that here. Let's see if there's anything else. Tab, and it just goes down to the bottom. Okay, that's fine. Public struct game. Implement for the game. This seems fine. So this is all fine so far. It's down here, this graphics clear. That needs to be like that. And the graphics black needs to be like that too. Oh, and graphics present. So those three. Okay, so save that. And let's do glib mod. We're gonna have a ball library, so we might as well bring that in. And I think that should be pretty good. Now of course we need a ball library to work. Let's comment this out. Not worry about that right now. And I should be able to run this as it is. So and cargo run. This will, ooh, no, okay. Use of undeclared, oh, right. I need to fix, why is my Berserker bot doing this, like constantly turning on and off? Is it every time I'm coming back into Rust JSON, it's like freaking out? That seems interesting. Katali, hello. We're creating, well, yes, you can highlight lines. It's bang line. And then I think you just do bang line again to make it go away. And then there's bang help, I think, to sort of, or just bang line by itself without a line number, and that will make it, you know, stop. They'll tell you what you can do with it. Yeah, I might have missed it. Or I think you did show me one in the main RS, and then you undid it, and then I did see it because of that. I did see the problem in main RS because of that, so that was super helpful. I am a little bit sad that the Twitch highlighter tool here doesn't show the highlights. But someday they say that they're going to make it so you can even choose what file to go in. Okay, let's see. What was I gonna do? What's that error again? Use of undeclared type or module. Right. So in our cogwall.toml, we have to use we have to go find it. So I suppose this would be another use of a what is it called? It would be a full out extension as opposed to just a snippet. If I want to, oh, I want to go to crates.io. Because I wonder if there's an API where I can come in and grab what the latest is, and then a extension would be able to just tell me, and I can say, okay, well, if I want to do something like this, GGEZ, I guess like cargo toml GGEZ. So my prefix is going to be, I guess, maybe GGEZ. Maybe it should be gtoml. No, I think just the name of the thing. That should be it. Then body is going to be just this line right here. With, of course, you /out. This will have to be updated every time there is a new update, obviously. And then, oh, I forgot a description down here. The description is going to be set up the library for development with GGEZ. And down here, description. Use GGEZ. Yeah, whatever. Set it here. I can now just say, oh, this is a cargo.toml file. Okay, so this can't go in here. This has to go in here. So create snippets for toml like that. Now I can say, what? Oh, look at this. It thinks it's plain text. That kind of sucks. Wait. Configure file associated with the .toml. Toml. There. Now that works. Okay, so I save. Now let's cargo run this. It will compile all this stuff. So a little bit of work up front, but that should save us a significant amount of time later on as we keep on developing. And we can tweak those, we can tweak these snippets as we go through with like more advanced stuff if we want to. People have been complaining about that for months. I'm surprised that, yeah, VS Code has been adding all sorts of things, you know, like really big grand things, but not necessarily like really tiny little, hey, just associate .toml with .toml. Icebox does have ambitious goals for it. I noticed that that also creates.io is now tagging it as in maintenance mode only, which I think is sad because I see Icefox commenting in the repo quite often. So he's still very engaged with it. It's not like it's an abandoned project at all. And I think new things kind of are being added to it or worked on. All right, so while this is building, let's go ahead and start creating our sphere, our circle. So you're back to not telling me it's working, but I'm not going to trust you. Where was this? Live.rs. Miguel, hello, good morning. So we're going to bring back the mod ball and use ball. Right, so there is one sort of negative. To make the line go away, it's bang line, bang the line number. And that'll make it go away. I don't have actually control over that. I can't actually make it go away myself. Oh, and I think you did it twice now, so you'd probably try it one more time. Oh, wait, no. Yeah, there it goes. Perfect. All right, so let's create a ball.rs in here. So I'm thinking this will be a pub struct ball. And if we just start with that right now, that should make this go away. And now it's like, hey, we're not using it. So cool. All right. What is it that we care about here? Also, you're still compiling? No, it didn't. Okay. Oh, look at that. It I saved it by accident, and so it actually tried to run. So we get our empty blank screen. So what I want to do is I want to start with a ball right in the center. So let's do that. When we create a new ball, we're going to want to have the location, which means we need to have the points. So we want to use GGEZ in algebra point 2. And so here we're going to have a location, and that's going to be a point 2 with subtype F32s. We want to implement ball, and we'll create a public function new. Do we want to create like the location of this? I'm not sure. We always know it wants to start in a center. So maybe we do want to like have a location. So maybe we don't need to use this. Oh no, I do for the point, for the type. That, never mind. Okay, so public function new, I want to take in a location, which is also a point 2. We're going to return a ball instance, and that's kind of going to be it. We're just going to return ball location. Oh, and you are going to be of type F32. So that should make that happier. It's never used. Well, we're going to change that. So over here, we do remember we need to get the width and the height. So this is actually something we can put into our rest.json here, because we use this all the time. So let window width, window height equals, it's going to be graphics, and it's down here. It's like get size or something, drawable size. That's it. Drawable size. We pass in the context. You need to be inside of here. We pass in the context, and that's pretty much it. Are there two? Oh, you are closed. Like that. You need to be not underscored. And now we have access to the window width and the window height. Thank you, Katali. Stacking, well, it was great having you here for a short time. Have a drive safe. All right, so we create that. You need to be tabbed in. So let's then like add that in and put this, because we always want to just store this so we're not constantly grabbing this. So our game is also going to have the window width of an F32 and the window height of an F32. And so we can just store these in here too. Window width, window height. Of course, they're not being used yet, but let's not worry about that. We're also going to be storing our ball. So an individual ball is going to be a type ball. And then we need to create a new one. So let ball equals ball new on our location. Well, okay, so we need to create a location. Which means we need a point 2. So let's bring that in here. All right, so let location equals point to new, and this is going to be in a center. So it's going to be window width divided by 2.0 and window height divided by 2.0. And now our ball equals new, and that's just going to be the location. And then we'll add our ball into here. So that's it for the ball, and then we need to draw our ball. So in draw here, we have oh, well, we're gonna have to have a color in the ball too. So color is going to be type, use GGEZ, graphics color. This is the type color. So let's just set the color to white right now. So that color equals, I do remember like we can use the rands to sort of like get the random color, and that would be a great another sort of like Rust.json snippet to use, because that just there's some boilerplate for that too. Okay, so let color equals, and in this case, I don't have access to graphics, do I? I guess I have access to each of these things as it. No, okay, I didn't think I did. So, let's just bring in graphics only, and then we'll just say this here. Like that. Graphics color, and then we'll just create a graphics white, and now color. So we'll save that. We need a size. So a radius, that's going to be an F32. All of these balls will be the same size. So let radius equals, let's do like 15.0. And so now in here, we have our new ball. We pass it in the location we want to be, but we now need to create the actual like graphical part to put onto. Velocity and acceleration. Yes, we will need that. I guess I'm just not going to put that in there right this second, because I'll just put it in as I need it. I just want to get a ball on the screen. But yes, you're correct, Kotali. Let's now let mesh equals, and so this is going to be graphics, the mesh builder, new. Okay, so then we want a dot circle. All right, so what is our draw mode? Well, I think that's graphics dot or colon draw mode. Fill. We have our point. This is going to be the location. So that's going to be self.ball.location. Our radius is self.ball.radius. Our tolerance is 0.01. And our color is self.ball.color. Then dot not buffer build. I hand it the context. Fill shouldn't have, no, I think it does. This is whatever fill returns is a draw mode. So it constructs a draw mode that fills shapes. So it's sort of like new, and it just auto configures for whatever we want. Yeah, it does feel a little bit weird. I don't remember this being like when I first started with GGEZ, so I think this is one of the new changes. So we're going to question mark this because build does return a game result. And then we need to draw this to the screen. So that's going to be graphics.draw. You know what? It might be : draw. There it is. We'll hand it the context. And now the drawable, so it's going to be a reference to the mesh. And then parameters. This is a tuple. It's going to take a location, and it's going to be the offset location. So I actually just want this to be a point to new 0.0 and 0.0. And then anything else, I'm just going to ignore. And then we're going to question mark that because it returns a game result. So I think, what are you upset about? Oh, field is private. So I need to make location, radius, and color public. And let's try this. And there we go. We have a ball in the center of the screen. Perfect. Let's update our snippet too. So the big thing, it's not really, I'm thinking in the library right now, we know we want to bring in, let's see, this was fine. I want to bring in this point too. So in this library, use that. We know that we want to have the window width and the window height in the game struct. So that's right here. So that we're going to end you, come down, do a new tab. Let's actually just you end like that. So we're going to have a new tab. Then we're going to have window width of type F32. You close there. New tab, window height. Okay, and then comma. We implement for the game, so now we need to get that line from the drawable size, which means also context needs to be underscored. So we'll let that, you'll be double tabbed. And then we want to put down there like that. So inside of game, we're going to have the new tab, and it's just going to be the window width. So like the window width and the window height. Like that. I think that's all I care to do right now. In Ball, so creating a new library, like a new library file like this. See, I don't know necessarily that we're thinking like what's going to be in the library, so I don't know if I want to create that right now. That should work that way. So I think we're fine. We have the ball in the middle of the screen. Let's now make it. Now we're going to do what Katali, you're suggesting. I'm actually going to do better at get this time, and I'm going to commit as we go through this. So ball is in the center of the screen. So now we want it to move towards the mouse, which means it's going to need a velocity and an acceleration. So let's add those in. So I don't think these can be pub, so we're just going to have a velocity, which is going to be a 0.2 of f32, and an acceleration, which is a 0.2 of f32. And we're going to have methods to sort of work with this. So initially we have 0 velocity and I guess a tiny acceleration. We can have it like move down like we did last time. Let velocity equals, it's going to be a 0.2 new, and it's going to be 0.0 and 0.0. Let acceleration equals 0.2 new. Let's do like 0.01 and 0.0. So that will just move to the right a little bit. It'll probably move pretty fast. And then I'm going to add in our velocity and acceleration. We need the ability to update the location, which means we need to update the velocity. So we're going to have an update function in here. So public function update. We just need a mutable reference to self, and I think that's it. We're not going to return anything. Instead, what we're going to do is we're going to just add the acceleration to the velocity, and then add the velocity to the location. And we found out last time that nAlgebra, did we discernibly find out? Well, it doesn't implement plus. I wonder if there's like a method that we can use for that. So let's go to nAlgebra. Isn't it better to have an f32 as acceleration so it speeds up uniformly on both directions x and y? Well, so that's going to be interesting because sometimes we may not want it to form, like, because that would be in an angle like that, like always at a diagonal. And sometimes we want it to go like a little bit more to the left and a little bit less up. I think it depends upon what direction we want it to go. But yes, I think that we're going to have a scaling like a speed. And we're going to multiply that by the acceleration after we normalize it. So it's going to be a little bit interesting. We're going to update the acceleration every single time once we figure out how that works. Okay, so nAlgebra documentation. You know what's also interesting is if we go back to GGEZ, go to its documentation. What version of nAlgebra are we using? Oh, this is not in alphabetical order. So, wait, the little tilde is 0.18. So if I go here, is it now set for that version? Yeah, 0.18. And what are you? Okay, 0.18. So it's the same version. So I want to see, is there like an add? I think we did look here for an add. And I don't think we saw it. Like we want to add points together. Just geometry point add. No, I don't think that's what I want. Yeah, the NAlgebra docs are a little bit tough to get a hold of. So if we take a look at point 2, it doesn't really give us anything. So it's I guess we'll just take a look at point. So here's this trait implementations of add for a matrix. Yeah, so I got to point, but I'm not sure. Close add. I'm not sure this is what I want. These docs are 100% correct, but so bad at actually being helpful. Yes, yeah. All right, I'm just gonna say we'll just do it ourselves. Maybe it'll have like the magnitude will help us out. I don't know. If not, the Nature of Code book has the math in it. We could just pull out and just do it ourselves. Okay, so in our update, we want to take our acceleration and add it to the velocity. Well, what does that mean? That means we're gonna say let self.velocity is now going to equal to the velocity of x. So we need a new, self.velocity.x. So equals self.velocity.x plus self.acceleration.x and then self.velocity.y equals y plus. All right, so just add x and y together to get what we want. And then after that, we're going to do the exact same thing with location. All right, so this should now make it move to the right. You can guarantee that any linear algebra operator you can think of is probably in NAlgebra. It's just I can't figure it out from the docs right away. That's great. So now let's update. So in update, we're just going to do self.ball.update. And if we run this, our ball should now move to the right. And it did extremely fast. We can do that entire thing where we get the delta time and multiply it, and that will make it slower. Or I can just make it incredibly small numbers, and that would work too. At increasing speed, yes, that's true too. So let's make this smaller number. And yes, it does increase its speed as it's going because I've got like my foot on the acceleration and that's a constant. All right, so now I need to know where the mouse is in this like in the game, and can like get a point for that. So that's the next thing. In live.rs, I need to get the mouse location. And I think GGEZ has that. So there's GG input mouse utility functions. Event when, okay, so maybe these functions will work and I could just call a function off of it to grab the mouse location. There's this one, mouse motion, that might be good too. Position, get the current position of the mouse cursor in pixels. Complement to set position. Wait, I can set position of the mouse? Ooh, I can grab the mouse so it can't leave the window. Interesting. Huh. This seems like an anti-pattern. Most people don't like their mouse just suddenly disappearing and appearing somewhere else. But okay, so I can do GGEZ input mouse position. So let's do that in the main library here. So GGEZ input, and then down here, I'm going to update the ball, but before that, we need to get the mouse location. So what does it return? Oh, it returns a point too. Perfect. So let mouse location equals input mouse location. Oh, position. And we hand it context, meaning that you need to not be underscored. It returns a mint point too. Huh. All right, so we're gonna get the mouse location. We're gonna need to pass this mouse location into the ball. Thank you, Danny. So we'll pass the mouse location, and then that will update that. Mint is an abstraction layer for algebra libraries to interop between libraries. Oh, nice. I wonder if Mint would have better, would give me better results. That might be interesting. Let's head back into the ball. Our update is going to take in a mouse position, or mouse location, which is a point to F32. You think Mint is just traits without implementations, then NAlgebra implements it, and others implement. Okay, that's interesting. So we're going to get our mouse location. So we need to know what direction to go in. Well, the easiest way to do that is to take our current location and subtract the mouse location, and that gets us a point that is both the direction towards and distance and speed too. So we're going to get, I think this is going to be just like direction equals self.location. And this is where that subtraction would come in really handy here, because I don't think I can do self.location like dot. Is there a subtract? See, I'm not seeing like a subtract function available to me here. There's a bunch of different things. All right. So this is gonna be a new point too. And for the x, we're going to say it's going to be the self.location.x subtracted from the mouse location.x. All right, so that will give us our direction. Just try minus. I think we've tried minus before and it didn't implement it. So if I do something like this, let other equals self.location minus mouse location. Okay, maybe it works. Let's comment this out. I could swear I tried it with add and it didn't work. What type does other say it is? An N algebra base matrix of type F32, whereas these are point F32. Point F32, point F.2. Okay, let's see if it just works. I'm just gonna make this a direction. So we have a direction that's pointing towards where the ball, like where the mouse is from the ball's position. But it's this entire length. So if I add that in, it'll just teleport the ball to the mouse, which is not exactly what I want. I want to now normalize this this point, so it's really just a tiny line pointing towards the direction of the mouse, and then we can scale that up by a speed. To normalize, I need to get the magnitude of the direction here. Can I get the magnitude? Is that a thing? A synonym for norm, aka length. Wait, can I normalize? Can I just... computes the L2 Euclidean norm of a vector. Okay. Deprecated. Okay, so don't use that. I think this one, maybe? This may be moved to the alga crate in the future. So function norm, it needs to be on a matrix, but we now have a matrix, kind of. It's just a normal norm, so it's not self, so can... I don't even know, like n, so whatever that input is. So if I do let, so this is going to be like the normalized direction. So if I shadow direction here, so direction equals direction dot norm. I mean, it doesn't hate it. It applies, so it normalizes it. And now I want to scale it up. So now we're going to have that that speed that you were talking about. I think who was it? Katali, yes. So let's have a speed. It's going to be f32. It's going to be a scalar value. We're going to make this like 0.001. Maybe even slower than that, so we could just really see what's happening. And so after we normalize this, we now need to multiply the direction by the speed, which is actually going to be the acceleration. So we want to, that just becomes the new acceleration, doesn't it? Yeah, because now we're just saying, now we're moving in this direction. So we're just going to say self.acceleration is now going to equal the direction. Can I add? No, it's going to be multiplied. So can I say direction times self.speed? I expected. Oh, okay. So a point found in F32. Wait, can I do a 0.1 in this case? I can do a 0.1. So speed could be a 0.1 of F32. It's like 0.001. Expected struck dimensions U2, found dimension 0.1. Okay, so yeah, it does. So it wants this to be a 0.2. Okay, so I can do that. So will this be a 0.2? And this will just have to be the same for each. 0.001. Oh, and 0.2. We don't need U anymore. Okay. So that sets our acceleration. Let's see. Let's just see if this works. No, of course not. Expected struct point found. Wait, expected self.ball.update. Mouse location, expected struct point. This is a 0.2. Found struct 0.2. Wait, is it because it's a mint and therefore it's different? Can I into? Mismatch types. So can I just do dot into? Okay. All right, so that was a little bit too fast. Let's make that a little bit slower. 1, 2, 3. Maybe even slower. So it's moving to the right. It's not moving. It's not moving down where I want it to go. Okay. So that is multiplying by like this amount, which is that is to the right and down. So that's not exactly what I want it to do. So we're getting the direction of the direction. Now, if I run this again and have my mouse in another direction, will it go towards the mouse? No, it's just always going to the right and down. So it's not. That's not helpful. So we're getting a direction. Self-location at minus mouse.location. We're normalizing the direction. What is norm? It returns an N. I think this is different now. I mean, do I need to get the return value of it, or is it also side effecting? No, okay. So it does need to have that. They're going to take the direction and multiply it by the speed to scale this up. And that's like we're overriding acceleration with that. The problem is that it's always ending up going the same direction. So I don't think this is doing exactly what I want it to do. If we take a look at the book, here's how this is working. We're getting our mouse vector, so that's our point. We're getting our direction, which is subtracting the mouse from the locations. That I think we're doing the opposite. So we want to subtract the mouse location from self.location. I don't think that would make a difference, but we could try it. This is still moving down and to the right, so that's cool. We now normalize the direction, and then we multiply it by, like we scale it up by something. So we are trying to do that. We then set acceleration to this direction, and then we do our velocity add. They're limiting the top speed, and then location add. So this isn't happening. Like the acceleration equals direction isn't what we think it is. I wonder if we can print out, if we can like debug print the normalized direction and see what it is. So can I debug direction here, and once again here. So I want to see, does normalize return something different? It's possible it's also like not working the way I want it to, or that I expect it to. Okay, so our mouse is up and to the left. Look at this, every single one is huge. Oh, look at that, normalize is not doing what I think it does. Yeah, that's not normalized. That's just a number. It just made it a single number. Okay. Euclidean normalization is not what I want. Are there other normalizations? There's LP norm. The L2 norm. You think I want dot normalize? Is there a dot normalize? Right, but this one said deprecated. Use matrix dot normalize. So yeah, probably normalize. So let's try that. So if I just do dot normalize, now I can't multiply anymore. So what are you now? Matrix F32. Try multiplying by a scalar now. Okay, so now if I multiply by like 0.0001. Expected struct point found. Oh, okay, so your point, you are a matrix. So you need to be a point. Can I into? Type annotation. So, okay. So I need you to be a 0.2 of F32. Okay, it's not yelling at me anymore. Let's see what it says. Hey, look at that. So now we have a ball that is constantly trying to get towards the mouse. So there's a couple lessons that we learned during this time. Let's see. I don't need this debug anymore. First of all, we do have some of these mathematical operations available to us, just not necessarily the ones we'd expect to have. Big oinky. I need a PID controller. What's a PID controller? I don't need to do this because we're able to just do minus between two different points. I thought we had that before. Like I tried plus and it just didn't work. Direction, we're gonna normalize. Then we convert it from a matrix type into a point type. So this can now be self.speed, which means this is back to just an F32. Oh, so I don't overshoot the mouse? Oh, yeah. So that is actually something they get later in a book. So go ahead and relaunch this. and I'll show you what the book. So the book is actually the same way right here. If I reset, it overshoots just like this in this example. Now if we move onwards, they do an entire array. I'm out of time, so I can't do all of them. But then, oh, in the next chapter, they're going to, like, it talks about forces. So let's see if we can find that. That's here, forces. So this is where we can basically say, okay, I want the forces to always like apply a friction, or I want to like slow down and never go past the mouse cursor. So that's going to be this next chapter. So yes, we will implement something like that probably in a later one. I think because I'm out of time, I'm gonna have to go get ready for work. But if any of you want to fork this code, try it out, and then maybe like add in the vectors, so you can have like many of these balls all playing, like, you know, going towards the cursor, that would be really interesting and fun. Something else that might be really interesting and fun is putting multiple mouse positions. So like not a mouse position, but instead like a gravity well, like in a couple different places. Yeah, exactly. See the interactions between them. And then there's all sorts of artsy stuff that can be done from this. I know that oh, what is it? And on Coding Train, Dan Schiffman recently did an entire. He did a video on visualizing a black hole, which, I mean, this is a super simple version of that, but basically it's visualizing light as it's being affected by gravity. So that's kind of what we're doing here, except in the most simplistic form. But that being said, I'm going to go ahead and commit this code. So we have a ball moving towards the mouse. I'm going to push this on up. I have a link to I don't think I have a link to the code down below, but I think I do have a link to my Git repo. And you can go find the code there. I'm also in the VODs. I'm going to put the link to there. Let's see if I'm still logged in to Git on this computer where I have my the other chat window. GitHub. No, of course not. I need to log in. I think last time I didn't log in. I just skipped it and went to Brooks builds, nature of code and Rust. And then I need to go to Twitch. Oh, and it won't let me log in through there. Okay, fine. I'm logged out on all of my browsers. That's perfect. What I can do, I think this is what I actually did last time. I switched to the ending screen. And then I can go open up my browser that I don't want anybody to see and get it here. That's what I'm going to do. All right, so nature of code and Rust, grab that, come over here, and here is the link. So it is 8:20. It is a little bit after when I usually start. So I'm gonna go and get ready for the rest of my day. I hope you all enjoyed watching me like create the snippets and also create a ball that sort of follows the mouse. I'm hoping that you all have a great rest of your day. My next planned stream is going to be Friday morning at 6:45 a.m. Mountain Time. And until then, Have a great day, have a great week, and I'll see you next time.